So we're looking at section 8.2, which covers graphing more complicated rational functions. So we're going to be graphing rational functions as well as identifying zeros, asymptotes, and end behavior. So as we have seen, there can be breaks in the graph of a rational function. These breaks are called discontinuities, and there are two different kinds. When a rational function has a factor in the denominator that is not also in the numerator, an infinite discontinuity occurs at the value of x for which the factor equals 0. On the graph of the function, an infinite discontinuity appears as a vertical asymptote. Then we also have when a rational function has a factor in the denominator that is also in the numerator, a point discontinuity occurs at the value of x for which the factor equals 0. On the graph of the function, a point discontinuity appears as a hole. The graph of a rational function can also have a horizontal asymptote, or even an asymptote that is a line that is neither horizontal nor vertical. This is determined by the degrees and leading coefficients of the function's numerator and denominator. So what can your function tell you? First thing you want to do is factor. Put your function in factored form, both the numerator and the denominator. So first you look for factors that cancel on the top and bottom. These are the holes or the points of discontinuity. So in this case here, got x plus a would cancel, and the x's would cancel. So that means we'll have holes at x equals negative a and at x equals 0. What's left in your numerator, the parts that don't cancel, are going to be your x-intercepts. So in this case, we've got the x minus b, means our x-intercept will be at x equals b. Our vertical asymptotes, or the infinite discontinuities, are the zeros of the denominator that don't cancel. So in this case, the x minus c. So that means we will have a vertical asymptote at x is equal to c. When you do your domain, it's very important. You'll have to include both the holes and the vertical asymptotes in the problem areas of our domain. So in this case, we'd have x not equal to 0, x not equal to c, and x cannot be equal to negative a. Horizontal asymptotes are going to be a little different. They're going to depend on the degree of the numerator and the denominator. So we'll go down to the next slide here to look at what that looks like. So what you want to look at is the degree or the power of the numerator and the denominator. If the top degree is less than the bottom degree, you're going to have a horizontal asymptote at y equals 0. If your top degree is equal to the bottom degree, what you do is you take the leading coefficients of the numerator and the denominator in standard form and turn those into a fraction, and that's going to be where your horizontal asymptote is. Last case is if the top degree is greater than the bottom degree. In this case, there will be no horizontal asymptote. Instead, you're going to have a slant asymptote. So what you'll need to do is you'll need to use division. So you'll actually divide the numerator and the denominator. Whatever the quotient is, that's going to be the equation of the line that is your slant asymptote. One important information about the horizontal asymptotes. The horizontal asymptotes are the same as the end behavior. So if it asks you what's the end behavior of the function, the y values are going to be going towards whatever your horizontal asymptote is. So it is the same as your end behavior. So for our directions, first thing you want to do, factor the numerator and the denominator. Then you want to look for any holes and vertical asymptotes. Then check for horizontal asymptotes, find the domain and range, and graph the function. So first thing first, you want to look for any holes. So is anything canceling in the numerator and the denominator? No, nothing is canceling, so we're not going to have any points of discontinuity, no holes. Vertical asymptotes are coming from the denominator. Set that factor equal to 0. We'll have a vertical asymptote at x equals 2. Looking for a horizontal asymptote, we look at the degree of the numerator and the denominator. These are both degree 1, so what we'll do is we'll take the coefficients and put them into a fraction. Each of the coefficients are 1. So 1 over 1 will get us a horizontal asymptote at y equals 1. Now, since we have a horizontal, that means we will not have a slant asymptote. Domain, x cannot equal 2. Range, y cannot equal 1. One other important piece of information we can get from this is coming from the numerator. Anything that doesn't cancel is telling us where we're going to have an x-intercept. So in this case, nothing canceled, so we'll have an x-intercept at -1. So we'll draw our vertical asymptote at 2. We'll draw our horizontal asymptote at 1. I meant to make that first one dashed, so imagine that one's dashed. And then we know we're going to cross our x-axis at -1, so we can put that point there. Based on that, we should be able to see which quadrants we're going to be in, kind of these diagonal ones over here. But since we can check, we may as well. So we can graph our function x plus 1 over x minus 2. Be careful when you graph these. Make sure you put your numerator and your denominators in their own set of parentheses. Otherwise, the calculator might follow the order of operations and not do it correctly. Sorry, my window was a little off. And I must be a little off somewhere. What did I do? X plus 1 over x minus 2. So let me change that real quick. And graph it. There we go. So I was right, we're going to be in the bottom left and upper right quadrants. And then we can just do our little sketch here using those asymptotes as our guidelines. Okay, let's look at another one. So the first thing we'll want to do here is factor in the denominator. So this will factor to x plus 4, x minus 1. So first thing we do is we check for anything that's going to cancel. Nothing does, so that means we're not going to have any holes. Vertical asymptotes, that's going to be stuff in the denominator that didn't cancel. So in this case, we'll have x is equal to -4 and x equal to +1. So this is going to look a little different than we've seen already, just because there are 2 vertical asymptotes. Horizontal asymptotes is based off of the powers, or the degree. Degree of the numerator is 1, degree of the denominator is 2. So in that case, the degree of the bottom is greater than the degree of the top. We're going to have a horizontal asymptote at y equals 0. Because we have a horizontal, we will not have a slant. So our domain, x can't be equal to -4, x can't be equal to 1, and our range, y can't be equal to 0. Last thing we want to check is our x-intercept that's coming from the numerator, anything that didn't cancel. So we'll have an x-intercept at -1. So we'll graph our asymptotes. 1, 2, 3, -4 is about here. X equals 1. And a horizontal asymptote at y equals 0. We know we're going to cross at -1. And let's go ahead and plug this into our calculator just to see what it's going to look like. So we'll have x plus 1 divided by x squared plus 3x minus 4. We graph, and we can do our shape based off of that general shape for us there. So it looks something like this. Like this with our crossing. And then something like